Hello, my name is Cheng. My topic is overview of synthetic fibers and the specific dyeing process. First is the introduction. We know that a synthetic fiber is a kind of chemical fiber which is synthesized by raw materials or made of collectively chemical fiber. And when compared to the natural fibers, it has some excellent properties like the high strength, fast drying, good elasticity, and antibacterial properties. Nowadays, the dosage of synthetic fiber is increasing faster and faster, and the application field was also extended. Here are three principal methods. The first one is carrier staining. It was used to help synthetic fibers dye under low temperature. Due to the small molecules, it can occupy the sites before the dye stuff combined with fibers. And through this way, it can also increase the dye absorption level. The second way is high temperature dyeing. We dye under the closed dyeing vat, and the temperature and the pressure is greater than the normal. So this way it can improve the dyeing rate and increase the absorption amount. Third way is small cell dyeing. On the high temperature and dry condition, dye stuff could spread into the fiber fast. In terms of polyester fibers, it always was made for the production like the shirts, jackets, children's clothing. And the bottom part is the basic synthesis for polyester fibers. When dyeing polyester fibers using creasing method, we know that the macro cracks formed by creasing method can sustain high stress, and the orientation occurs at the location of micro cracks when the fiber yarns are deformed in the direction of applied pressure. You can see this picture. During this experiment, despite there is a significant increase in the dye concentration in the dye bath, it can't lead to a substantial growth in its absorption by the fiber, which can be explained by the microcracks factor. The figure 2 shows the reaction of two amino acids. The figure 3 shows the synthesis method of 9016 from aliponitrol and formaldehyde water. During this process, we use sulfuric acid as the catalyst. The polyacrylonitrile fibers obtained by free radical polymerization of acrylonitrile monomer. It can be used for medical equipment, for example, artificial organs, ultra-pure water finishing. Dyeing acrylic fibers with canonical dyes and using Germany surfactants, it was found that the rate of dyeing process was increased by increasing the dye temperature and decreasing the concentration of surfactants. In terms of polypropylene fibers, it's a small plastic fibers used in a wide variety of applications like the packaging and labeling, textiles, plastic parts, and laboratory equipment. It's also a major polymer used in nonwoven products. The last one is polyurethane fibers. Polyurethane is a polymer composed of organic units, when joined by complement links. While most polyurethanes are thermosetting polymers that do not melt when heated, and the polyurethane fibers have a good elasticity, and the rupture elongation can reach to 800%. Last part is the expectation of sustainable dyeing process. We know that in order to reduce the pollutant that discharge from textile dyeing process, we should take measures to reduce the use of dyes and auxiliaries. The first way is try using eco-friendly types of auxiliaries to replace the traditional type. The second way is attempt to minimize the dosage of auxiliaries by doing pretreatment. The third way is using enzymes, which is biodegradability, to replace the chemical agents. Appreciate for your watching.